All right, we're going to look at the properties of log homework. And so remember that there's really three big properties that we'll use. There is the product property that says that if you have log base b of like m, and you could write this as log base b of m plus log base b of n. And then there is the quotient one, which is like if you have a division, log of a division, that would be log base b of m minus log base b of n. And really they're just following some familiar exponent rules. We also have, if you add the power on something like m to the r, that this is equal to r times log base b of m. So really the exponent gets to go to the front. And that's just an application kind of that very first rule, that product rule. So those are the three that we're going to use. I'm going to number them just so that way that can help when we're talking about it here. So when you see the properties of log, one of the things that I like to change is not seeing radicals and rewriting them as exponents. So here on number one, we're going to rewrite this as natural log of xy will be to the 1/3 power, and that's all over wz squared. Again, it's natural log of all of that. So that's just using the exponent, that radicals can be written as exponents. Okay, so next what I would want to do is the big thing that I see kind of sticking out is a big division problem, natural log of a division problem. So by number 2 of our properties up above there, this one will rewrite as natural log of xy to the 1/3 minus natural log of wz squared. And so then by number 3 up above, by number 3, I'm going to use the power rule to put the 1/3 in the front of natural log. So that's 1/3 natural log of xy, and then I'm just keeping everything else the same. It's really natural log of that whole quantity. Okay, so then this is natural log of xy. That's a product. So by number 1 up above, by number 1, we can write this as natural log of x plus natural log of y. And then there's a 1/3 hanging out, and it's in front of that entire natural log, so we're going to end up having to distribute it. Similar to the next part, we again have a product in here and the minus. So I'm going to stick the minus in the front and rewrite it as natural log of w plus natural log of z squared, but keep it in a parenthesis because that negative has to distribute to everything. But I do notice one more thing first. This power 2 on that z can go to the front. So this is really 2 natural log of z, and that's by number 3 of those properties up above. So then distributing 1/3 to both of those, we're going to get 1/3 natural log of x plus 1/3 natural log of y minus natural log of w minus, again this is distributing, 2 natural log of z. And that would be expanded as much as possible. We can't use the properties to break those up anymore. All right. For this next one, again, those radicals I want to rewrite. So this is going to be log base 2. That fourth root means y radical 2 to the 1/4 power. And I also have the square root of 2 inside there, so I could rewrite this as log base 2 of y times 2 to the 1/2 to the 1/4. And there's a couple different ways that you could deal with that. Right away what's popping out at me is exponent rules, that y times 2 to the 1/2. If you have a power on it, that 1/4 can go to each of those pieces. So this is really log base 2 of, you could say y to the 1/4 times, if you have 2 to the 1/2 and you raise that to the 1/4, that's really 1/8. I don't know if that's really the best way to go. As I'm saying that, I'm thinking maybe it's better if we just take that power and use number 3 and put that in the front, because 1/8 kind of sounds weird a little bit. And again, if you went that route, we should end up with our final answers being equivalent. So let's use the number 3 where we take that power to the front. So that's going to be 1/4 of log base 2 of y times 2 to the 1/2. Then using our number 1 rule where we have that log of a product, this is 1/4 of, it'll be log base 2 of y plus log base 2 of 2 to the 1/2. And so we have that power like inside our log, inside the parenthesis, I mean. So that 1/2 can go to the front, again, by that power rule. So we're going to have a 1/2 log base 2 of 2, and this is log base 2 of y, all that times 1/4. Now remember that log base 2 of 2, that's saying 2 to what power makes 2? That's just going to be a 1. So this is actually equal to, I can distribute the 1/4. We're going to have 1/4 log base 2 of y plus a 4th times a half is an 1/8. So you can see that did pop out. Times 1 is just going to be 1/8. So my final answer expanded is going to be that guy. All right. So it says explain why the product property of logs does not apply in the student's work. So as you're looking at it, we do have log of, we have 2 logs being added together here. And so we know we can write that as a single log of the product. But here's the big deal. The product property said that the number inside here had to be positive. Because when we multiply a negative and a negative together, we end up with positive. It looks like our answer comes out and it's beautiful in 3. But we're not even defined to begin with. We're undefined. The argument always has to be positive. The argument of a log is always positive. Okay, so keep that in mind. All right, next guy, we want to condense these. That means we want to put them into a single logarithm. And so right away what's standing out to me is the coefficients in front of these logs. So going backwards means putting them on as exponent. So we're going to go do that. So this is going to be log of x to the 6th minus log of y to the 1/3 minus log of z to the 2/3. Now I have log of these, or these 2 things, and they're subtracted. You can write that as a single log and write this as division. And then we have another subtraction. So again, you're subtracting these logs. This is going to again be in the denominator, becoming log of x to the 6th, y to the 1/3, z to the 2/3. So we wrote it as a single logarithm. One other way that you could have thought about this, instead of taking just the 1/3 here, if you took negative 1/3 and negative 2/3, you could have been thinking this is log of x to the 6th plus log of y to the negative 1/3 plus log of z to the negative 2/3 power. Now you have a whole bunch of logs being added. We can rewrite this as a single log of their product, x to the 6th, y to the negative 1/3, z to the negative 2/3. Negative exponents mean kind of reciprocal or divide by it. So I know that this is going to be log of x to the 6th over y to the 1/3, z to the 2/3. And if you just see like a negative log, you're thinking that's a negative exponent, that's a negative exponent, and so they're living in the denominator like you'd expect. So either way, it's fine on those. All right. Again, kind of putting these 2 guys together, or 3 guys together. There's going to be log base 3 of 60 over 10 minus log base 3 of 2. But again, this is a subtraction of 2 logs, so that means we're going to divide. So it'll be 60 over that 10 times 2, because again, that went in the denominator. If you want to see why that's working, maybe you kind of missed that step. It's not really a or, but why here? If we wrote it out as log base 3 of 60 over 10 over the 2, because of that subtraction, we divide, and it's one single log. This is 2 over 1. We multiply by 1 over 2, because dividing by a fraction multiplies by the reciprocal. That's log base 3 of 60 over 10 times 2. So I just did it in that one step. So this is log base 3 of 60 over 20, but that's log base 3. 60 divided by 20 is 3. And so log base 3 of 3 is saying 3 to what power makes 3? That would be a 1. The exponent it's asking for is 1. All right, and we skipped number 4. You can check on it if you want to, but we'll leave that to you.